before doing this test, I'm gonna be checking the iPad here to make sure I can read you guys. All right, I have everything ready. I have time setting up this. Let me take out the charger part. We don't need this. There we go. And now I have the iPad ready so I can read the comments. Let's wait until more people connect, okay? So we can explain what we are doing in here. So this is gonna be very cool. Yesterday we test to explain a similar test with this cell. Let me make sure the tape is okay. I want to make sure everything is perfect or almost perfect. So we test the cell yesterday, discharging at 45 amps, okay? And really gave me very nice results. And since it gave me those good results, I decide, okay, let's go for the full 50 amps discharging rate. And I have everything ready for do that today. So the cell again is a RS, the new Reliance RS50, which is the 5,000 milliamps cell, 70 amps claimed discharging rate. And I mean, it's the one that compete with the 50PL. Okay, this cell actually is arriving on Friday to the store. So I have two samples here. We're gonna be testing now. What's up, buddy? Hey, we're gonna be testing now, man, the full 50 amps. Before do the 70, I wanna do the full 50. I really wanna know if I can call these cells 50 amps continuously. I know it does 45. I mean, actually, March claimed 45. I'm gonna push 50 and see if we can do 50. And not only that, yesterday the cell gave me at 45 amps discharging rate, what 5137 milliamps. I'm sorry, milliamps, which I'm very surprised. I want to see how much I can get with 50 amps. I mean, I don't expect even get 5,000, but let's see what we can get here. So we have, I guess we have quorum to do this test. We have 7 persons connected and everything is ready to go. I don't want to make a very long video of this. I just uploaded a video and I invite you to do it. I was welding, buddy, welding um, with this cheapest welder, welding stainless steel with copper, not nickel, copper. Check that video. I'm gonna start using stainless steel instead to use nickel for my sandwiches. You're gonna see why. Stainless steel is less conductive, yes, but have more resistance. It welds stronger, and do not have corrosion because it's stainless steel. Okay, check that video. That's gonna open the door for many things. Okay, let's start testing. Okay, I was waiting to see if more people connect, but I mean, I don't want to make a long video, guys. You're waiting, and that's gonna be very fun. Okay, let's start showing you what I have. That's the cell. It's the same setup as yesterday. These cables are 6 gauge, super overkill. This setup is for the 100 amps plus power. And I'm gonna be testing the new equipment. That's the my torch. That's the new version. Allow me to do 50 amp discharging rate continuously, which I'm gonna do. I have that connected to the computer. That's where we are gonna be monitoring everything. Okay, in the computer, because I have better control here and we can see this better. So we have all the information. Again, I'm gonna explain very quickly. We're gonna see here, this is the current voltage. The battery is fully charged and has been sitting, for 1 hour. It's set right now to 50 amps continuously. This is our power. Right now is 0 because it's deactivated. We're gonna see how many watts it's producing at 50 amps. Here we are gonna see the watts hour, and here we are gonna see the milliamps that it's gonna be producing. Okay. And the most important part, guys, is we want to keep an eye in here, the one that say NTC. Actually, let me zoom this so you can see even better. NTC, this is our cell temperature, okay? We're gonna see right now we have the room in 25 degrees. Well, the cell is in 25 degrees, and we are gonna get ready. So you tell me if you wanna see this screen or you wanna zoom it out. I believe you wanna see all this. Look in the cell is nothing. We don't see anything in the cell. I will see this screen, to be honest. So as soon as I click here on, it's gonna activate those 50 amps. We wanna see how much the voltage goes down here. This is the important part, okay? How strong is the cell? We're gonna see the, yeah, I'm gonna keep it like that. I guess it's the best way, buddy. So, and see, here you're gonna see that current. We're gonna see the sagging here. We keep an eye how many watts is producing, and keep an eye in that temperature. We're gonna see for how long we can go. Okay, let's do this. Don't waste more time. I'm ready. 1, 2, and activate it. There we go. 46. We have 48. We have 49, and yeah, it's gonna be 49 something. Look at the voltage, 3.67. That's great numbers. 50 amps continuously. That, are you kidding me? Now keep an eye see how it's gonna start going up that temperature, because it's a lot of current, okay? And we're gonna go continuously. FYI, I did a change now. I gonna let the cell, if past 85 degrees, it's gonna stop. I changed the 80 to for 85 just for the love of the test. So I hope we don't have a fire here. All right, let's see how it's doing. Look at that temperature. We are in 37 degrees already. Keep going in 50 amps. 3.6. We still have 3.64. Look at how stable is that voltage. Are you kidding me? That's great. 181 watts from one single cell. 180 watts. Wow. On a single cell. We already consume, look at that, over 1,000 milliamps already. This test is gonna go quickly, because it's gonna consume that power very quickly, that capacity, We are in 46 degrees already. Look at how stable. It's still 3.58. Still 3.58. Let me put it in this way. You put a multi cell P45V in 40 amps, and you go in below 3.5, believe me. Very strong cell, this cell. 3.55 yet. We are 51 degrees. Yes, it's gonna heat up quickly. We're really pushing hard. 50 amps. Look at that, 176 watts is still producing. We have, look at that. We're gonna go to 1900 milliamps, which is what, 40% of the capacity burned already. Well, not yet, but yeah, man, look at that. 2000 milliamps already are gone. 56 degrees, not bad. 56 degrees, not bad. Let me check how much time we have already. We have over 2 minutes and a half running the cell. Unfortunately, I don't see that in the screen, the timing, so I have to read it for you. But it's crazy. 172 watts yet, man. Buddy, 3.44 volts. Look at that. 61 degrees, and we have halfway already from the cell capacity gone. So it's in 50%. 50% and still 3.4. Great. That's great, man. Yep. Look at that. Unbelievable. Still 161, 69. Look at that. At this stage. Let me see how much time we have already. We have 3 minutes and a half in the test. 3 minutes and a half. So at 50 amps continuously, that's great. Buddy, look at the temperature, only 65. We are in good parameters right now. 66 degrees is excellent. Really good. But it's still 3.3 volts. With already past, that's a lot of capacity gone. Look at that. Still 49. I mean, it's well 50 amps continuously. I believe after we go below, I will says 3 volts, 2.9, this maybe is affected. Let's see, 158 still, 158 watts. Look at that, 3.5, 30, almost 3600 milliamps. Look at that temperature. Now it's going to the little bit concerning zone, 70 degrees. Technically up to 80, we're okay. Up to 80. I don't know if it's gonna touch 80. It's set to 85 to stop. I mean, if we can finish this below 80 degrees, okay, this cell is gonna be something else. Okay, look at that, what I mentioned. It started affecting. Now it's in 46. 46 because it's sagging a little bit now, the cell, obviously 3 volts, 4 amps hour already. Are you kidding me? Temperature 73, not bad, not bad, 73. 3 volts, we're still in 3 volts. Are you kidding me? Yes, yes, I mean, this cell maybe can do it. I mean, remember, I don't have that set here, but look, okay, okay, I'm getting excited. Look at it, almost 4,500 milliamps, and we're still in 2.9. That's great numbers. Temperature 74, we are good. 74, we are still in range, in the healthy range. 75, look at that, man, look at that. 40 is gonna go 4,700 milliamps. It's already beat the P50B. It already beat a bunch of cells already. Okay, under 50 amps. I mean, it's 40. Yes, 41. But it's the meter how in the way that do it. Look at the temperature is still 77. I'm surprised. Yes, but it's because it's taking care in here. This limit, I don't know if it's my equipment to be honest with you, or is the cell. Look at that. It already gave me 5,000 milliamps. 5,000 milliamps. Look at that. 2.55 is gonna stop. It's gonna stop. And I'm gonna stop this test now because I want that data. I'm gonna show the data and to help the cell. Look at that. It never passed 80 degrees. Look at those numbers. It's gonna go up. It's gonna go up. Maybe to 79, I believe. 76. No, it's going down. That's great, great, great numbers. Look at how much gave me against 51.29. Are you kidding me? 51.29. Um, yes. Remember, the freaking cell is considered for 5,000 milliamps only. And look at how much it's giving. That's insane continuously. And I abuse of this cell already. I mean, this is the same cell that I pushed yesterday. And I like to let me blow some air. Look at how the temperature will go down now. All right. I like to blow the cell to put it in a very healthy temperature quickly. Still 53, that's fine. I'm happy with that. So I don't want to destroy the cell. I mean, it's not destroying, it's still in healthy numbers. But wow. I'm really surprised with the capacity that it can give under that much load. Um, I don't know why at the end, which I don't care too much at the end. I mean, for the testing perspective, yes, I'm concerned because I want to maintain a 50 amps continuously. Um, by the other side, using the cell, you don't care. I mean, if that happened, it's just it's able to discharge. Will get down to 25 amps. How hot will get down to 25? Buddy, if discharging at 50 amps, it doesn't touch 80 degrees, imagine a 25. 25, I don't think, I haven't tested in 25 because I'm honest with you, I know what the people want to see first is the high numbers. That's how I started. But I expect 25. I mean, I cannot tell, but I will don't be surprised if the cell is still below 40 degrees. I mean, 25 is nothing for this cell. I mean, look at that. It's 50 continuously. The important part is this. Listen, this continuously from start to finish. That's if we can make it below what the manufacturer says, which is 80 degrees, the maximum, like I did now, I can call the cell 50 amps continuous discharging. Remember, it's outside of a pack. I mean, much call it 45 amps, okay? I need to clarify that. What criteria he took to do that, I not 100%. I don't know if it's much online, much. If you are online, I would like to see your input, why you call it. Maybe, hey, maybe it's the sample that he have. I'm testing only one cell right now. I mean that I have. I mean I have two cells, but I haven't touched the other one. I'm still with the same one. Maybe I have a really good sample. Maybe he's using different parameters. Yeah, yeah, I agree with that. It could be by safety. I mean that he don't want to go maybe over 75 degrees, and that's why he decided to stop it there. It's a good possibility. That's the reason why. But I already tested UC 50 amps, and I haven't reached the 80s. So anyway, 70 is high. You don't want to go that high. You don't want to go over 70. Let me put it in this way. You don't want to go over 70. Technically, we're in the specs. Okay, it should be fine. 45 continuously will go down to 2.5 and hit in. That was in your testing. Yeah, in my testing, I with safely. Okay. Well, in my case, I just tested and 3 times I get this test done, and it haven't reached that high. I mean, and I'm pushing even now even harder, 50 amps. Again, it could be my sample. Could be my sample. Not all the samples are the same. Maybe correct. Yeah, that could be the thing. Now, my question is, it. I guess maybe it's my equipment somehow. Maybe it's dropping. Is the equipment who is dropping? I don't think it's the cell. Maybe my equipment. The good part is I have a second tester. I'm gonna do the same test with the other tester and see if my tester does that again. If the tester does that again, could be the MOSFET of my tester are getting too hot and maybe the tester is protecting the MOSFET. If that's the case, I'm gonna modify my testers and putting heavy fans to make sure the MOSFET stay cold and I can stick to 50 amps discharging. That could be very easy. The reason why it's doing that, and much, you're completely right. The fact that it's decreasing from 50 to 36, maybe that helped the cell don't reach that 80 degrees. Yes, I agree with that. That probably is the thing. Still, look at that capacity. That's pretty impressive. Yesterday, I was able to push 45 all the way, and I believe in the only few seconds left. Not your sample. The IR of your tester is too high to allow 50 amp. Yeah, yeah. Maybe for temperature. Yeah. Let me read that much. Um, you need to parallel tester to each take. Yes, I'm gonna be doing that much, but not for 50. I'm gonna do it for 70, and I'm gonna be using. Look at the idea. I'm gonna be using one of these bars. So what I'm gonna do, connect both testers in this copper. This is very thick copper. Both testers in this, I'm gonna make it shorter to connect both testers here, and then the battery. My battery clamps are gonna be connected here. So they are gonna be able to put that continuously. So Technically, the tester is supposed to be able to do 50 amps. I don't know if it's problem with temperature from the MOSFET. If that's the case, again, I'm gonna put the heavy duty fans to be able to do that. I'm gonna test with the second tester later. The same test. Since I have two identicals, so if to see if it's a problem with this specifically, or is both of them they act the same. So if that again, I'm gonna modify the tester. If that's the case, to see if I can able to sustain those 50 amps. It can do 50 amps at a certain voltage range. Oh, okay, that's possible too, because I remember the CBA unit. It's something similar happened to the CBA unit. Okay, that makes sense. That makes sense. It could be by voltage. If that's the case, yeah, I have to do it in parallel. Absolutely, even for 50 amps. Yeah, actually, that's easy to test. I'm gonna test that with my power supply. Uh, Decreasing the voltage. I mean, taking, well, I cannot take 50 amps, but well, I have two power supplies. I can do it with both of them in parallel, to push 50 amps, and see if I can replicate that issue with the power supply. In that way, I rule it out. It's not the cell. Obviously, it's not the cell. So, but yes, I can dial this with the testers. Anyway, people, thank you for being here. I hope you like this test. It's a great cell. I have to say it. It's a great cell. Very good option between the 50 PL or this cell. Great, both of them, they are great. I know the 50 PL can push harder. I know it can push harder. Mosh already test that and approve it. But this cell is a really good option, and this cell is a little bit cheaper than the 50 PL. So it's a great option. By the way, I have this cell that is arriving on Friday. I have already one person that bought 1/5 in one shot from what is coming. It bought a lot. No, actually 1/5. No, 10% from what I bought is, and plus a bunch of other people. They got it already. I put it in pre-sale because I know the sale is already. They leave customs already. It's on the way. It's based in UPS. Is arriving this Friday. The sale. So great. And I have the RS40, which I haven't tested yet, and I haven't seen it yet in person. The RS40. What else? This Tuesday is arriving. Hopefully, let me see where is wood. My samples from 30 PLs, the EV 30 PLs, are arriving on Tuesday, which I'm gonna send that to Much. That quickly, so he can test that. That's gonna be cool. Okay, this time I'm not gonna make a longer video. Check the video that I just posted, welding with the cheapest welder that I have in the store. I mean, cheapest good welder, which is the $139 welder, 10.5 kilowatt welding copper. I attempt 0.3 with stainless steel, not nickel, stainless steel. And I welded very nicely with 0.2. Hey, the cheapest welder. That's something that even the key weld cannot do with a $139 welder. Check it out. Check the video. And I mean, that's gonna be awesome. Let me read something. It can do 50 amp, for example, with a 1 volt battery. Exactly. So yes, I know that much. I had the same issue. With the, I believe was the CBA unit. Cannot do. I I cannot remember the numbers. I don't want to, give you false information. But I have another equipment that, yes, when it's too low the voltage, it cannot do high amps. That happened even with chargers. Sometimes cheap chargers, you cannot charge very low voltage in higher amps. Like I have a charger here that I cannot charge more than 18 amps in a single cell. But if I put it at least two cells, so over 5 volts, I can charge all the way to 40 amps or 45 amps, I believe. So I know there is equipment that have limitation. I hope this one is not the case and is something temperature maybe. because I was having good hopes for this equipment. Anyway, man, I cannot wait to get the CBA unit with the equalizer. Um, Design of load, I ain't limited to 150. Come on, buddy. 150 only limited. Oh, 150 to what? To you says 150 to 0.9, but over 2.5. Okay, man, but still 150 is great for testing. I wish I have 150. Now I'm limited to 50. I'm gonna put it in parallel so I can go 100. But the only thing is to take the information. Maybe I'm going to technical with this. Let me show you something that I got. Maybe Much can see it. Um, my idea. Let me move this here. My idea is I got these chunks. Let me explain what is this. I have one that is 100 and one that is 200. So the idea that I have is with this equipment, with this equipment, I can go. Let me see. This one is the 100. Yeah. With this equipment, I can go with the two parallels load. Actually, I can put three if I want to go over 100, and then connect them. I mean, before the clamp, and then the clamp goes here and here. So the 1 over plus 100 amps that I'm gonna be pulling are gonna be passing by this equipment. With this equipment, is on a torch, I can collect all the data. So, because the problem is when I put that in parallel, the equipment is gonna be reading only, for example, 50 amps only, each one individually. So the data is not gonna be accurate. For example, for the milliamps reading with the watts hour reading is not gonna be accurate because each one is gonna be taking its own. But if everything passed by here, with this one, I can collect that data. My only concern is this is not as precise. I mean, as much equipment or the other equipment, but it's gonna be good enough for set baseline and to have an idea how good is the. I mean, it's a lot of work setting up this, but I want to do it. I want to do it. Just let me read the comments, guys. Stay 40C at 25 and 5 and because under. Yes, I mean it's 25 amps with a cell like this. That's nothing for that cell. Even hey, you don't need this cell for 25 amps. You can even get a a multi cell P42B, which is very cheap, and that one can do 25 amps and no problem. I mean, yes, it's gonna sag more obviously than a tablet, but if you really don't need too high in a pack, no yet, but maybe soon. Yeah. So actually, Much is gonna be testing. I read that you're gonna be testing like a pack simulator, like simulating how it's gonna behave a test in a pack. That's gonna be great. I would love to see those testing and learn how you're gonna do that. He's gonna test. If correct me if I'm not mistaken, Much. He's gonna be testing like when you have a cell in the way that we are testing, the cell is outside, is getting air from the air. It's not inside a pack. So in a pack, you can expect even more heat. Okay. So, but I believe he's gonna be simulating somehow how the cell is gonna behave, maybe with a heating pack or something, testing the cell, rising the pack simulation versus free air. Yes, that's gonna be really nice because even if it's not perfect, it's gonna be close to see how it's gonna behave that cell under higher temperature. And remember, when you are in a pack, not only go higher temperature in certain point, it take longer to cool down because you have more heat, more mass accumulating that heat for longer time. That's another aspect that we need to see. Not only raising for how long, even if you stop consuming, that heat is gonna stay there for longer. It's gonna take maybe longer to raise because you have more mass, you have copper, you have, a bunch of things, but it's gonna take longer to cool down as well. So that's why it's important to know those testing, like I will call it like real life um, pack testing. That will be nice because again, you can make a test, and you see my temperature don't go into 50 degrees. Let's see, maybe 30 amps, but that's not gonna be the case when this in a pack. That's why when I build my packs, I like not to go more than 40% from the cell capacity. I mean discharging. I don't like to, for example, if the cell is rated for 60 amps, I don't like to heat 30 amps because I know it's gonna heat up when it's in a pack. That's when it's continuously. That's absolutely perfect. If you are going longer heat as each cell is in here will take longer to cool down, says the cool pack. Exactly, exactly. So, and that's why it's very important to know those testing that he's talking about. And if you want to see that testing, I don't know how long he's gonna start doing those testing. Go to his Patreon. I mean, I want to see that because that's very interesting to know. That data is very important to know how good you're gonna build your packs and how much you're gonna push that pack. This is important. For example, if you are building a pack for let me explain you, for a battery or a go-kart, for example, for those racings. I mean, there is a circuit and you are continuously pushing in a race. That I mean, that's when you want to know that information. If you are in an e-bike that you are gonna be, for example, cruising long time in high speed, you want to know that information. You really want to know that information. I have a client that asked me to build a pack. For example, he want to do Uber Eats in his e-bike. I mean, using the e-bike. So he's gonna be continuously pushing hard that cell. I mean, in the 50 miles per hour, stuff like that. You wanna know that information. Very important because you will know if you are pushing too much for the temperature perspective or not. That's the important part to know that testing. So if you haven't searched in Patreon for much battery much, check his Patreon. $2 a month. Come on, I mean it's not even a coffee. And it's not only this. There is a bunch of information. If you like my testing, he already have this done already. I'm just doing it for myself for fun. Let me read the comments. Let me read the comments, guys. I wonder if will be worth it putting the pack with thermal conductive resin for higher. So yes, I mean that's something that I was playing with. There is for the 3D, for example, for the 3D printers, there is a filament that is thermal conductive that I wanna play with to help the pack releasing or moving that heat outside of the cells. So yes, I will love to play with that, but at the same time it's dangerous because the thermal conductive filament at the same time is conductive. For your many people doesn't know that filament is conductive, so anything that is touching copper, it can transfer current. So we have to be very careful to not to short a cell. So we need to be very careful where we put that filament. So that hyperstream, let me read that much. The word causing the weight penalty. That's a big question. Yeah. That's another thing. That is a heavy filament. That's a heavy filament. It depends. It depends where you're gonna be using that. I mean, but I mean, it's a bunch of going on here. All right, guys. I'm not gonna make this longer. I promise. I'm not gonna be like yesterday. Even when, let me see how long I have this video already. 30, almost 35 minutes. I like it. I really like this test. I mean, I have good hopes for this sale. I do not have a 50 PL, unfortunately, to compare results because it haven't arrived. I know my 50 PLs are gonna be arriving on the 8th to the port. Okay, to the port, which the 8th, I guess next week sometime, to the port, and then customs. I don't know how long customs is gonna take. Sometimes they take 3 days, and then they ship it. Sometimes they take 1 week. I seen the worst. The worst, it took 2 weeks and a half. I mean, but that's not gonna be the case. Hopefully, I mean, so I put it in the website for the 20th of this month, which is super conservative. I'm sure it's gonna arrive before that, but just in case, I rather tell you it's coming the 20 and then inform you, hey, I have that already. Just like the RS50, I put it to the day 14, and I know it's gonna arrive. Well, confirmed for Friday, but things happen, weather, many things that maybe is coming for Monday instead. Well, let's put it for Friday, okay? Okay, I know it take longer. For the people, hey, check the shop. I have offers for Labor Day. Check it out. I put in offer the JP30s on sale. I have a bunch of sales. Check it out. Even the spot welders. I have two spot welders in really good price. So take advantage of that. And hey, thank you for the support the store. Thank you for support the group. Thank you the YouTube channel. And hey, support Much. Much is here to answer even questions outside of his environment, like how I call it. So check his Patreon. I mean, sometimes he posts stuff for free. Check the Patreon. You can see, even if you don't want to pay $2. Come on, $2. If you are here, come on, $2. I mean, it's that makes me sick if you cannot pay $2. Hey, well, I don't know the situation every person, but I mean, it's $2 is shoot me something, and I hook you up. Take care. Thank you much. Have a good night. Hopefully, hey, as soon as those 30 PLs arrive on Tuesday, I'm shipping that expedite. So I'm gonna try to make those sales arrive by Thursday, or the worst case, Friday. Okay, so you can test that. I know you has been promising that because I says I'm gonna have it, but you know the story why I haven't received that yet. But anyway, have a good night, everybody. Happy holidays tomorrow, and thank you for support the store, guys. And I'm gonna fix my problems here, and hopefully we can do the 70 amp continuous discharge rate and know how for how long we can do 70 amps before the cell reach 80 degrees. Okay. Thank you. Have a good one. Good night.